So this is my second example of computing a difference quotient. So find f of x plus h minus f of x over h. In other words, find the difference quotient if f of x equals x minus 1 over x plus 2. So I have this, and I'm going to plug in my formula for f of x. I'm going to replace the x's with x plus h. And I get this, x plus h minus 1 over x plus h plus 2. And then I have to subtract out f of x. Subtract that. Right? And then divide by h. Now this is a mixed fraction. It's a fraction where the numerator has fractions in it. I don't like that too much. So I'm going to write, instead of dividing by h, I'm going to multiply by 1 over h. That way I don't, oops, I went too far. You have gone too far now. So I'm going to write it this way. So I put the 1 over h in front. Now what am I doing here? I'm trying to get a common denominator for the two fractions. So the trick here, remember the trick with the square roots was to use the difference of two squares, multiply by the conjugate. The trick here is to just subtract the two fractions. Write the two fractions as a single fraction. So I would need a common denominator. So the first fraction I need to multiply by x plus 2 over x plus 2. And the second fraction I need to multiply by x plus h plus 2 over x plus h plus 2. So now the denominators of both fractions have the same denominator, right? Now the denominator stays the same. The numerator, there's two different terms, this one and this one. And I want to multiply this out, and then you'll have a whole bunch of terms and a bunch of things will cancel. So I multiplied out the x plus h minus 1 times x plus 2 just by distribution. Then I put the minus, then I put parentheses, and I multiplied out the x minus 1 times x plus h plus 2 inside the parentheses. Why did I do that? Because this minus here applies to everything, all these terms. And if I try to multiply this out and do the opposite of each one as I go, I'm going to mess it up. So just put this in parentheses. There's always a minus here, so this is usually a good idea, right? Put these in parentheses, and then just distribute that minus the next step. And the next step will just be opposite sign, opposite sign, opposite sign, opposite sign, opposite sign, opposite sign, until you're done. Okay. Now, of course, this whole thing goes over x plus 2 times x plus h plus 2. Okay, now this step, again, I'm just going to distribute that negative. See how that goes? So, oops. Negative x squared minus hx minus 2x plus x plus h plus 2. So I'm just thinking change sign, change sign, change sign, change sign, change sign, change sign. Now things will start canceling. Look, see there's an x squared minus x squared. That's 0, right? 2x minus 2x is 0. hx minus hx is 0. Lots of these things cancel. 2h doesn't cancel with anything. Minus x plus x. Minus 2 plus 2. Right? So a lot of these things cancel off. Those two do. Those two. 2x and minus 2x. Right? X and minus x and plus x. Minus 2 and plus 2. The only thing I'm left with is the h terms. So I have a 2h and I have a 1h. So that's a 3h. So I get 3h over h times, and I still got the same denominator. Now the h's will cancel by division, leaving a 1 on top. 3 times 1 is 3. So right, actually leaves a 3 on top. So I get 3 over x plus 2 times x plus h plus 2. And that's the answer. So it's a bit of computation, but the idea is pretty simple. You're just combining the two fractions in the numerator and then simplifying.